Okay, so let's talk about while loops. So we learned a nice structure today. Today. On Thursday, we learned about something called a list. And we learned that a list contains a lot of elements pulled together into a nice little single item, single object that you can reference and that you can access different parts of it. And we also showed you in the last part of the class that it could contain things of multiple different types. So for example, you could have a list that had integers and floats and other lists and tuples, etc. They can all be stored in a list. Well, that's really nice, but in order to actually do anything with them, we need a way to progress through an entire list. And there's also a lot of other reasons why we might want to do the same operation over and over again. And so in order to accomplish that, we're going to introduce something called a while loop. So the basics of a loop are that they allow us, and by the way, this is in section 9.6. What you're going to find out is that your book, if you're following along in the text hits for loops first and then while loops. And the key is that really a for loop, the semantics of a for loop can't encompass the semantics of a while loop. So a for loop is not meant to terminate early. There's a lot of stuff in a for loop. It's a simplified loop, so maybe sometimes it's a little easier to understand, but the while loop is the general one. So they're going from a specific individual case and then generalizing. We're going to start with the general case, and then we'll go to the specific case, I think, in the next lecture, a week from today. So all that said, 9.6 is the chapter you want to read about while loops. So let's think about this for a second. Let's talk about the basics. So the idea with a while loop is that it allows you to repeat a block of code multiple times. Which means that, so this is, really the basis of a lot of sophisticated tasks. You do the same thing over and over again. That's what computers are really strong at. They can go through and they can do the same operations over and over without getting particularly bored, right? Okay, yeah, I already covered that. Let's look at our first while loop. And I'm going to change this up just a little bit, I think. So we'll come into here. I'll do a Control V. No, this isn't what I wanted to do. Yeah, this is okay. And at the end of this, I'm going to strip out this comment. You guys should read the comment, but it makes it hard to read here. We'll come in here and we'll do print done. Okay, so let's start at the beginning here. A for loop has essentially 3 different parts. I forgot to print out my my code today, so I don't know how I forgot. So I need to actually refer back to the handout every now and then. All right, so a for loop has essentially 3 different parts. It has a block A, right? This is the setup. This is what you do before you get to the for loop. In this case, it's just line 1. It has, it has the while condition, right? So this is the while. Then it has a block B, and that's lines 5 and 6. And that's what happens while you're actually executing the while loop. So that refers to, the stuff you do while you're in the while loop. And then there's this block C. And the block C is what you do when you're done. So let's run this. We'll run this. We'll go back to the first line. Okay, and now we'll kind of step through. We set up I equals 1. We just take our variable I, we put 1 in it. it's a holder. We ask while I less than 10, right? So this is a conditional. You should remember conditionals because we just got through with them on if statements a few lectures ago. A conditional compares some values. A relational compares two values and decides whether this statement, I is less than 10, is true or false. And true or false is a Boolean, and that Boolean gets substituted in for this expression. And as long as the Boolean value up here evaluates to true, what we do is we enter block B. And we go through block B until this condition is no longer true. So, important. Something in your code has to change to make that condition not true at some point in time, right? So we have to set up the condition here. Here we'll set I to 1. We evaluate the condition to see whether what we're looking for still exists, whether the condition we're looking for exists. We have some action we do, and then we advance the solution toward a finishing point so we can actually get done and not enter an infinite loop. At the end, right, when we're done with our while loop, when this no longer is true, when this becomes false, I is no longer less than 10, then we enter block C. And block C is distinguished from block B by the fact that it's brought back out, it's unindented, it's back out to the same level as the while. So we start out at one level of indent, at this point at 0 characters. We hit our while loop, we're still at 0 characters. To signify block B, we indent, I think we're indenting 4 spaces, but as long as it's consistent, the number of spaces doesn't really matter. And then when we're done, we return to our original level of indent, right? So now we can go through here. We've set I equal to 1. 1 is less than 10, so we enter block B. We'll print out whatever I is. Well, I is 1, so we print out 1. Now we have to increment I, and I goes to 2. And now we'll just keep doing this, right? So I is now 2, we print it, we increment it to 3, we keep going on, and if after a while we get I equal to 9 up in the corner here, right? Now I equals 9, we increment it again, now I equals 10. Well, 10 is not less than 10, 10 is equal to 10, so now this conditional, this relation is now false. 10 is not less than 10, that's a false statement. Yes, I'm recording this. This is a false statement. And now we'll drop out of block B and we'll head to block C. Okay, and now we can just print out whatever block C said, which is essentially done. All right, so that's kind of the first thing of a while loop. We kind of discussed it in terms here, right? I labeled the blocks for you. You can kind of see what's going on. And we actually did walk through these steps, right? If the conditional evaluates to true, if the condition evaluates to true, we enter block B. If the condition evaluates to false, we enter block C. When we reach the end of block B, we go back and reevaluate the bounds of the while loop to see what actually happened. Okay? Any questions on that? While loops are wonderful. This is the important thing. With for loops, you're always kind of progressing someplace. While loops, you don't actually have to progress. We can make a mistake over here, and this is a kind of easy mistake to make, right? If we say I plus equals 0, right, we get an error. Stopped running after 1,000 steps, right? Well, we hit 1,000 steps because we're actually in an infinite loop. No matter how many times we increment I by 0, we never advance toward making our condition false. So, we have to be careful. If we make this 2, right, now all of a sudden we start at 1, we skip 2, we go to 3, skip 4, go to 5, skip 6, go to 7, skip 8, go to 9, right? Because every time through this loop, we're incrementing by 1. All right? Let's see, is there anything else we need to talk about on this? We're going to get into this question a little bit more. And in fact, sometimes we will have loops that have an indeterminate stopping condition. We won't actually know when they're going to stop. In fact, we'll get into one of those today. We're going to stop based on user input, which is kind of a fun little test. You know, if our user is obstinate or dumb, it may never stop. And by the way, users are never dumb. It's us that program it, that make mistakes, that make them, it's errors we put into the code that makes it not obvious to them what they should enter. So you should always be thinking about, if I have a naive user, if I have a first timer, how do I make this so that it doesn't have mistakes in it that they might be prone to make? All right. This was a pretty simple loop. All we did was we counted, right? We started at 1 and we counted up to 9. That's pretty trivial, but it's fairly important, and it actually maps really well into lists. Because if we want to pull out parts of lists, what we really want to do is we want to start at the front of the list, and we just want to count up until we get to the end of the list. And then we know, for instance, let me put in CO2 levels here. Right, if we come back to our little Python tutor, we'll strip this out, we'll do a Control V. Right, we know that this creates a list, and we know that why is this not indenting for me? Ah, there we go. Okay, we know that this creates a list, and we know that if we want, we can say CO2 levels sub 0. Now, we can say print CO2 levels sub 0. I love that this keeps giving me errors. Right, we can say print CO2 levels sub 0, and that prints out the first member of the list. And we can do this again, and we can do print. Am I in live? Right, and I can do print CO2 levels sub 1. Right, and that's going to print out CO2 levels sub 1, which is this 2003 tuple 2003 322.16. By the way, what this list is supposed to represent is CO2 levels in the atmosphere in some measurement, probably parts per million or parts per billion. This is the year, and this is the concentration level. So we can walk through our list one at a time. What we may want to do, and you can see that all we're actually doing is every time through the list, we are incrementing the list increment by 1. And we could do this very easily as well just by saying, come up here and I'll say I equals 0. Change this to an I plus equals 1. Change this to an I, change this to an I plus equals 1. Right? So this is allowing us to walk through 0, 1, 2, 0, 1, 2, and we can keep continuing this pattern as we go along, if we want. Right? Now we're accessing 0, 1, 2, 3, right? So we have 2006, 323.91, and et cetera. So we can just keep walking through incrementing our variable I by 1 and kind of accessing all of these values. Well, this is exactly where a while loop is handy. So let's come in here and let's convert this to a while loop. Right? So we have while I, and now we have to have a conditional. Right? And what we want our conditional to be, I'm going to strip out everything from here down. Okay? And let's put in done again, because I like done, just to signify that we're done with our loop. And this is going to, well, I don't want to put this in quite yet. This block is going to be our block B as soon as we kind of indent it in. Okay, so now we have to figure out what we want I to be. Well, we know that I can start at 0, and we have that. That's in block A. And now we want I to count along until it gets, well, to the end of our list. So if we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like our list has 9 members starting at 0. we should also know that we have a length function that tells us how long our here's what we need to do here. There we go. Now we're seeing something. Okay, so now the length function is printing out that our value is 10, right? So we know that CO2 levels is 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that there are 9 indices, right? Well, that should start making sense to us. We want I to go from 0 to 9. The length of CO2 levels is 10. So what we want is we want to count up until I is equal to the length of CO2 levels. And as soon as it gets there, well, we know that we're past the end of our list, so we can actually stop, right? So we'll walk I from 0. It'll increment by 1, 2, 3, 4, etc. up until it gets to 9. 9 will be the last time it's through the loop. Next time it goes through, it'll be 10. 10 is the length of the CO2 levels list. So at that point, this condition will become false, and we'll drop down to done. So let's kind of pop all of these in, right? So now we have our code essentially finished. We'll take away our last syntax error. And now what we can see is that we're doing exactly what we were doing manually before by manually incrementing I and printing out CO2 levels. But instead, we're putting out our tuples one at a time, right? 201, 2003, 2004, 2006, 2008. Come on. 2009, 10, 11, 12, 13. And then we hit this done down here. So what we're doing is we're actually using our while loop to generate the indices for accessing all of the members of our CO2 list. And that's another very important and highly used, or big use for any types of loops, including while loops. And does this look any different? Yeah, they made it a little prettier. I'm not against pretty. I can do pretty. We'll just pop this in just so you can see there is actually no real difference here. All this is a change of the print statement, right? So now it's actually giving us a little bit more information. What happens if we do this? We can put I equals -1, right? And remember that -1 is actually a valid index. We can go all the way up to -9. Right? And when we do that, what we're going to do is we will start walking backward. Let's see. We can go all the way back to -10. Sorry. I got myself confused, and then the rest of the program didn't make sense, right? And -10 was a synonym for 0, right? 0 and -10 are the same index, and we can walk through incrementing by 1, and this time we're going to go through, we'll print out everything twice, right? We get all the way up to 2013, right? At 2013, after we print 2013, you know, this would be -1. And now we start over again with 0 all the way up to 9. Okay, so we can, you know, pretty much walk through any valid indices, and we can change how we want to do this. Like if we were to, in fact, go -1, I greater than or equal to 0, I minus equals 1, that should actually walk us backwards through the list I hope. Okay. And maybe not. What did I do here? Greater than or equal to 0. Okay. Okay, so there's a good question in the question bin. What am I doing? While I greater than or equal to minus 10. Okay. There it goes. Okay, so this walks us backward through once you get all the syntax errors, or once you get all the semantic errors out. All right. Remember that, we covered this Thursday, but remember that this first value refers to the member in the list. The 0th member of this list is a tuple, and then this second value references an index in the tuple, right? So this is printing out the 0th member of the 0th tuple the first time through, the first member of the 0th tuple the second time through, and so on. Okay, so just it'd be good to review that terminology, but remember that the first index, right, picks which item of the list we pick, and then if that is in itself a list or a tuple, the second item picks from there. Okay, so that should be back to the original. All right. This, by the way, this is a line continuation statement. If you notice, this is exactly the last, right? As soon as we go past that, we go down to the next line. What that essentially says is to ignore, that says my line got too long and nobody can read it anymore. So ignore the fact that I went down to the next line. Okay, so that just essentially, right, says there's an end of line marker here, but just ignore it. Okay, does it make sense? All right, let's do a little bit of practice. So I did a little bit of this already, although I think I did it poorly because I was being casual, fast and free with my loops. So the first thing we want to do is we want to actually write a while loop to count down from 10 to 1, printing the values of the loop counting variable I, or whatever name you want. I actually hate using I, because if you're trying to search for a loop and you're searching for I, and of course you'll hit this I, you'll hit, well, apparently that's the only I have in here so far. But I is any single character is too common. So I don't like to use single characters as pretty much anything. So we are going to use the character CTR for counter. And we're going to set counter equal to 10, because what the problem is asking us to do, and Ryan's right, you don't always need the line break character, but generally it has to break on a specific place, like on a comma. So, if you throw it in your test, we will take it. If you just use a little arrow and wrap it around, or actually, you guys aren't handwriting, you'll be typing it in. And actually, that's the last thing that I should have showed you. Let me just, so we want to count backwards from 10, and we want to stop at 1. So we can start at 10, we can say while, and we can pick our stopping condition. We can say while counter greater than 0, or we can say while counter greater than or equal to 1, whichever one we want. We can print out counter, right, which is our variable. And now, if we don't do anything here, what's going to happen is this is going to go into an infinite loop, right? Because we haven't advanced counter towards our solution. So I'm going to kill this. If this happens to you, you kill it up here, little red box. And now we have to advance counter towards our solution. If we do counter plus equals 1, well, that's going to be even worse. That's going to go in the wrong direction, so we're going to get farther and farther away from our solution. For this particular one, if we're starting at 10 and we want to progress towards 1, we want to subtract 1 from counter every time. And then I'm just going to come down here and print my normal done because I like printing done when I'm done. Okay, and this does exactly what we were asking to do. Count down from 10 to 1 and then stop. All right, cool. Oh, there we are. Okay, so that was the first practice problem. And now we can use that same thing, right? Now we've just generated the numbers from 10 down to 1. We know that our CO2 levels, let me grab those, have 10 items, so they go from 9 down to 0. So let's pop our CO2 levels in here, right? We now have all of our CO2 levels. We're generating counter, and counter can be an index. So now, instead of printing counter, let's print counter, comma, CO2 levels subcounter, right? So this will print the counterth 1. Now there's a problem with this. So let's see what it is. So we're going to get a list index out of range error. And we're going to get a list index out of range error because the first time through, counter is 10. And CO2 levels go from 0 to 9. So there's two ways to fix this. The first way is we can just subtract 1 from counter. So what this will do is when we come down through, right, we're going to print 10, but we're going to reference 10 minus 1. So it'll reference counter 9. And this should be okay because we're going to go through this loop 10 times. Counter will go from 9 down to 0. Right? So that's exactly what we're seeing, right? The last one printed is our 0th counter. The other way we can do this is we can be a little tricky, and we can just reorder our statements so that we do our decrement before we hit where we're accessing the counter. This will still stop at the same time because as soon as this gets down to 0, when it comes in at 1, we'll make it 0, we'll operate on counter sub 0, and then we'll come back up again, and 0 is not greater than or equal to 1, so we'll pop out. So that should work exactly the same, except that instead of counting from 10 down to 1, we're counting from 9 down to 0. And if we wanted to, we could even fix that by putting a +1 in here. Okay, so I just want to show you that there's a number of different ways to actually write these loops, depending on what you're trying to put out and depending upon what you want counter, how the relationship you want between counter and the list item you're putting out. Okay. So that shows you accessing any member of a loop or any member of a list. And you can do anything you want when you access that member of a list. If we wanted to, we could add 1 to every member. Well, it's a tuple, so we'd have to generate a new tuple. But we could do something like Right, at this time I think what I think I'm doing is just stripping out, I'm turning this into a list of integers. And now if we look at CO2 levels, right, all I did was I created a new list, right? I overwrote all the levels of the list, and I threw out all of the concentrations and just kept the 0th element, just the date. So you can the point here is that you can just operate on the list to do whatever you want. You have access to the list. We can turn it into something else. We can do this. Maybe we discovered we were always low by 1. So we can access the concentration. Right, which is that counter sub 1, and we'll just add 1 to it. And then end the tuple. I think that's correct. Yeah, that should work. Right, and now if we look, our CO2 levels, right, we've just done an operation on everything, and every one of these, like this has been changed to 383.47, 358.29, etc.